I like this question. A line drive is hit. So a line drive is basically a very shallow, high-speed baseball hit. Shallow, high-speed baseball. So there's our little baseball cruising at, it has a very small mass, and except it has a very high speed. This is the initial speed. And our outfielder has quite a large mass. I'll give it a big M. And no speed at all. No horizontal speed, at least. He jumps up, catches the baseball, and it's asked, while he jumps up in the air to catch the baseball, how much is he actually knocked backwards? How much is he put in motion by this baseball? We can use conservation of momentum. It's a good concept to use when there's collisions, because we know it's going to be conserved. Momentum's not going to change. The momentum before the collision is going to be equal to the momentum after the collision, or the final momentum is going to be equal to the initial momentum, because it doesn't change. A momentum initially is carried, at least in the horizontal direction, is carried all by the little baseball. And let's remember, the definition of momentum is mass in motion, with direction information to be always kept in mind. You can so don't forget about it if you don't put vector signs over top, or if you're not always paying attention. You can anyway just recognize that in complicated situations, especially when there's going to be changes in direction, momentum in different directions has different signs, has to balance each other, has to balance itself out. But here in this case, it's going to be an inelastic collision. The baseball is moving along. The momentum is being carried completely by the little baseball, moving very quickly. And then once it's caught, which can be represented quite abstractly by this simple diagram, the baseball's caught, this entire combined coupled mass in an inelastic collision. This would be an inelastic collision. It's carried away with some kind of velocity, final velocity, which is the question. Conservation of momentum, the final velocity is going to be, the final momentum is going to be carried by the baseball and the man coupled together with an unknown final velocity. Since those two momentums are equal, you certainly can calculate that.